I have a brief story about the importance of measurement. So, I recently had a conversation with a peer of mine. His name is Ryan, about retention in the Marine Corps. He said that while he was speaking to his supervisors at Headquarters Marine Corps as a manpower analyst, he claimed that the Corps' retention tools were incentivizing high quality officers to exit the Marine Corps while incentivizing lower quality officers to stay in. But his supervisors were not convinced and asked Ryan to provide viable data. Ryan couldn't. As a matter of fact, he didn't even know how to clearly define a high quality officer versus a low quality officer. Realizing how difficult it would be to define high quality and low quality officers and collect viable retention data, he abandoned his idea and turned his attention to better defined problems. Perhaps if Ryan had the proper tools to measure and frame the problem, his ideas would have been more positively received by his supervisors. Ryan needed, but didn't have, improvement science. So one of the 6 Carnegie Foundation's improvement principles introduced in Learning to Improve is we cannot improve at scale what we cannot measure. Improvement science has several tools that contribute to measurement. Make sure organizations only measure what matters and prevent embarrassing scenarios like the one Ryan faced. These tools build onto each other, but the tool that contributes most to measurement is the driver diagram. The driver diagram consists of an aim, which is the ultimate goal of an improvement project, drivers that serve to target the aim and trigger change ideas, and change ideas. In improvement science, the practitioner does not simply create a driver diagram from scratch. There are several tools that inform and feed that driver diagram. The aim evolves from a well-defined problem statement, while the drivers are influenced by root cause analysis that comes from a fishbone diagram and an interrelationship diagram. The fishbone diagram and interrelationship diagram precede the driver diagram so that the problem is well defined before measurement is even started. So Ryan pinpointed retention tools, which is something called solutionitis, or focusing on a solution instead of a problem. He also said that high quality officers were leaving instead of low quality officers, which was probably another premature statement. We quickly begin to see how many pitfalls we are already avoiding by using improvement science. What's a problem that's irrefutable? Officers are choosing to resign from the Marine Corps, many of whom the Corps would like to retain, some of whom the Corps would rather not retain. By asking why, we can get a better understanding of that problem. Eventually develop an aim, drivers, and change ideas, and the associated measures to assess their effectiveness. In improvement science, there are measures to assess the effectiveness of drivers, changes, and something called balancing measures. When making changes associated with the retention of high quality personnel, it is easy to overlook other areas that may suffer from the changes. Balancing measures are designed to put measures in place to identify the extent of the damage to those other areas. For example, prior to 2012, the Marine Corps had trouble getting officers to apply to several high visibility programs because many of the highest quality personnel wanted to perform in high visibility positions instead of participate in high visibility programs. The solution was a Commandant's Career Education Board. It's called for short CCLEB, and a Commandant's Professional Intermediate Board, the CPIB, where officers were automatically screened so that all seats got filled. Although the program successfully ensured that all seats were filled, there were several unintended consequences, including officers going to programs they did not want to go to, and many officers missing out on career opportunities that would have helped them in the long run, like company command, for example. Balancing measures would have identified those possible unintended consequences and a method to measure their impact. Now, retention in the Marine Corps is extremely complex, and the Marine Corps has a plethora of programs aimed at selecting and retaining high-quality officers. I say this because I'm not going to solve this potential problem in an 8-minute video. The purpose of this video is to show how using these tools can help the Marine Corps define problems and work toward changes that will solve well-defined problems. When Ryan's bosses started asking him for data, he could have informed his bosses that measurement comes after an aim statement is developed, drivers are identified and ranked using an interrelationship diagram, and changes are recommended. Change in today's organizations is complex, and therefore a systematic process that looks at a problem systemically is necessary. Ryan could have responded to his bosses, "Great points. Have you heard of this tool called the fishbone diagram?" Now, back to measurement. Let's say we've jumped over several hurdles and have an aim statement to increase retention of high quality officers by 10% and reduce the retention of low quality officers by 10% by July 2020. A driver could be retention tools. A change recommendation could be to eliminate the C-CLEB. This change could easily be implemented, but without measurement, its effectiveness would be questionable. Measuring canceling C-CLEB is as easy as stating whether it was done or we failed to stop C-CLEB. The measurement for the driver could be how many high-quality officers labeled retention tools as a reason for staying in, and how many low-quality officers labeled retention tools as a reason for getting out. If trends show more high-quality officers staying in and more low-quality officers getting out, then that driver is effective in accomplishing the aim, while an opposite result would reveal that the change was ineffective in accomplishing the aim. In addition, there would be balancing measures, in line with the unintended consequences that we mentioned earlier. For example, we can measure the impact of career opportunities via the number of high-quality officers filling critical billets like company command versus number of low-quality officers filling critical billets. We can measure career satisfaction via the percentage of high-quality officers happy with their assignment versus the number of low-quality officers satisfied with their assignment. Using only one driver and one change idea, we've identified 6 possible measures. Driver diagrams typically consist of 3 to 5 drivers and several change ideas per driver. Using improvement science, Ryan could have advised his supervisors that he had plans to collect that data. All those measures exist for a specific reason: to measure the effectiveness of change. Many times, measurement is used for research or accountability. If measurement for change is collected in the same manner as measurement for research or accountability, it's likely that the wrong data will be collected. The tools available in improvement science make sure data is never collected for the sake of collecting data. All data collected in improvement science contributes to what changes stay and what changes go. Moreover, improvement science minimizes negative unintended consequences and maximizes positive learning and change. The Marine Corps is collecting a lot of data right now, but it is being collected in a manner that just shows the current state of the Marine Corps. The Marine Corps takes that data and compares it to ideals, then conducts short working groups to discuss changes that could possibly close the gap between how things are and how leaders would like them to be. The Corps needs to do better than that, and improvement science is a good place to start.